My name is Carlos Caceres, and this is my project for the HPCC Systems Internship Program, which is Practical Applications of Generative AI Technology, specifically between OpenAI and HPCC Systems. My mentors are Lily Zhu and Roger Dev. So basically, OpenAI has been receiving a lot of traction lately, specifically through their ChatGPT web-based service. However, their API has also been leveraged many times for whether it be personal assistance or app creation. However, I wanted to see what the potential use cases could be of OpenAI with big data systems such as HPCC systems, specifically in use cases involving image recognition. So the objectives of this project were to create an OpenAI interface representing an emotion, taking in a number, and then generating a contextually appropriate response for that number represented in emotion. And this includes also creating an OpenAI ECL interface and learning more about the capabilities of OpenAI's API. So what was accomplished? An OpenAI interface that can take in a set of numbers representing different emotions and provide a contextually appropriate reading was created. And these are the four emotions of happiness, anger, sadness, and fear. And together, these emotions can then mold a response to provide a contextually appropriate response, such as a simple greeting like, "Oh, you look happy today." Also, a memory system was developed so that previous queries could be set to be remembered, so that information from previous requests could then be carried over throughout the conversation. And it was wrapped in ECL, which allows for responses and queries to be sent as a work unit. So important things that were learned were variable parameters, and this is what was used to basically create the contextually appropriate response to mold the model to actually create a response that we like, both in length and tone and function. So some of the parameters that were used was temperature, basically a randomness function based on a bell curve, value between 0 and 2, and at 0 it becomes deterministic. Top P, similar to temperature, however, it works by representing the amount of a node that was sampled. So 0.5 represents half the node is being sampled. Max token represents the amount of characters, where it's approximately the amount of characters each token represents. So frequency penalty, a modifier which penalizes the model for including two similar words that represent the same idea, and a higher number will usually lead to a split into more original ideas. Presence penalty will penalize the model for using the same exact words. So if it's a higher number will mean that the model will use is less likely to use the same words verbatim. Also, and another point that was learned was something called fine tuning, which basically the idea is to develop your own model using a prompt completion system. And this would allow you to mold the model to your own liking, both in form, function, tone. However, this came up with a lot of issues, namely being that it only worked on the older models, being 801 and Curie, and these models were completion-based, not chat completion, which meant that they were designed to complete a sentence, like fill in the blank, not create a new response based on a sentence. So it wasn't meant to converse with you, which led a lot of limitations on its use case, specifically in a use case designed to create a response. So in conclusion, as an exploratory project, OpenAI has a lot of use cases. It's just about analyzing its capabilities and understanding its tremendous potential. And specifically, fine-tuning poses as a particular interest for future points of research because of its design in which it takes in large amounts of data to train it, similar to an ENN. And that is my project for the HPCC Systems poster competition. Thank you.